Welcome to this tutorial. In this tutorial we are trying to understand the expression that we write for configurational entropy. Specifically we said that if you have n sites and so n is the number of sites, and if you distribute Na number of A atoms and Nb number of B atoms and Na and Nb add up to n, then we said that the total number of indistinguishable ways in which you can distribute this is given by n factorial by Na factorial Nb factorial. So, this is what we wrote omega, and so S is k ln omega. So, that is how the configurational entropy was calculated, and this is the number of microstates. Now, why is this so? So, this is what we want to understand. To do that, I am going to take a very simple case. I am going to take a lattice which has 4 points. Okay. So, n in this case is 4, and A I am going to take as black and B I am going to take as white. Let us say that I take 2 black balls and 2 white balls. Okay. Now, you can think of the total number of ways in which you can distribute 2 black balls and 2 white balls on 4 sides, and they can be calculated as follows. Suppose I put the first black ball here, B1, then I will be left with one more black ball and 2 white balls. So, the one more black ball can go here or here or here. So, if one is given, then there are 3 others, and this one can go here or here or here or here. So, there are 4 sides for B1, and now the next one B2, that has 1, 2, 3 sides. So, there are 4 into 3, 12 possibilities. Suppose if I also take the B2 to be one of the sides, then I am left with 2 sides. So, there are 2 atoms. So, they have 2, and the last one there is only 1. So, there is 1. So, 1 into 2 into 3 into 4. So, that will be 24. So, 24 is the actual number of ways in which you can distribute, but we are going to assume that we are not going to distinguish between B1 and B2. Suppose I put B2 here, this configuration looks indistinguishable from B2 here and B1 here. Okay. So, that means this is not the total number of sites, and similarly the W1 and W2. So, suppose the W1 was here and W2 was here. So, I am not going to distinguish that between W2 and W1 here. So, that means the number of different ways in which similarly 2 of them can be distributed is given by 2 factorial. So, it is 2 factorial and another 2 factorial. So, that is the total number of microstates that are available. So, 24 divided by 2 into 2. So, that is 4. So, 24 by 4, that is going to be 6. Okay. Now, what are these 6 indistinguishable ways in which the 2 black and 2 white atoms can be distributed? So, we can actually list them, because this is a small number of things. So, let me take this. So, there are going to be 6. So, let me do 6 of them. Okay. So, what are those 6? Let me say black is filled and white is open. So, this is black and this is black. So, this is one configuration, and it is possible that this is black and this is black. So, the other configuration is this is black and this is black, right. So, there are only 3. In the other 3, of course, so I am going to assume that this is black and this is black, okay, or this is black and this is black, okay, or I am going to assume that this is black, this is black. So, these are the only 6 ways. Of course, this is because of the indistinguishability. So, that is because we are not able to distinguish between these 2 and these 2. Suppose if I am able to distinguish this as B1, this as B2, or this as B2, this as B1. So, for every one there will be 2 more, right. So, there are 6 and so into 2 that will be 12, and for the same with white also. Suppose I can distinguish this as W1, W2 and this as W2, this as W1, then for each one of these there will be 2 more. So, so we have now configuration 1, configuration 2, configuration 3, 4, 5 and 6. These are if the black and whites are indistinguishable. If we can distinguish the blacks and whites, then that will give for each 4 different ways. The configuration will look the same, but one will be called B1, B2, W1, W2, the other one will be called B2, B1, W1, W2, the other one will be called B1, B2, W1, W2, and the other one will be called B2, B1, W2, W1. So like that. So then 6 into 4, that is the total number of. So if you have n sites and Na and Nb number of A and B atoms or black and white atoms that you can distribute, and if you are going to assume that among themselves A and B are indistinguishable, then you have to divide by this factorial Na factorial Nb, otherwise the total number of ways in which you can distribute is just given by n factorial. Okay. So, this is the basis of writing this omega expression. Once you have written that, of course, you can write the configurational entropy, which is what we did in the lecture. Okay. So, this is again a solved problem from Porter and Easterling. So, this is the same example that is given, taking a site with taking a lattice with 4 sites and putting 2 black and 2 white there. Of course, you can make it a little bit more complicated or slightly different. Suppose you take 3 blacks and 1 white, for example, or 3 whites and 1 black, for example. So, how many are the number of sites you can do in a similar fashion, and you can use the formula and you can compare and see that they always match. So this is how the counting of the configurations is done. Thank you.